there are actually two different types of mTOR, mTOR 1 and mTOR 2. mTOR 1 is the center of the research because it is thought that mTOR 1 plays a role in cell proliferation, cell growth, protein synthesis, all these kind of things. But when it comes to mTOR 2, it's been kind of difficult to elucidate it. But according to new research, I can say that it may also play a role in cancer, like mTOR 1, may also play a role in organization of cytoskeleton. So that's why what we're gonna focus is gonna be mTOR 1. And whenever I say mTOR 1, you should understand that I'm referring to mTOR 1, okay? So just FYI, and also wanna say something really quick. These drawings here were supposed to look like, the phospholipid bilayers, but now kind of looks like quadruple layers or something. Just want to let you know. Okay. So anyway, what are the specific biochemical pathways to be able to activate mTOR? First thing is moving inhibitor. Okay, moving inhibitor away from activator of mTOR. So if you remember from my first video, inhibitor of mTOR was TSC 1/2, and activator of mTOR is rehab, which is right here. I know it's kind of difficult to see here, but this is rehab right here, activator of mTOR, and the one right below rehab is the inhibitor of mTOR, which is again TSC 1/2. So what should we do in order to move inhibitor away from activation side of mTOR? First thing is resistance exercise, and second thing is growth factors. So what kind of growth factors? Specifically IGF-1, which is very well known, and I've been coming across a lot of people taking this specific growth factor, and also insulin, which is again well known and released by the pancreas beta cells, right? So if we take a look at here, we see both resting exercise and IGF-1 do the same thing by using completely different ways. They do the same thing by using completely different ways. So let me kind of simplify it. Okay, so let's say we have a road. Okay, and road is made up of two different lanes, and let's say first lane is called rest and exercise, and second lane is called growth factors, and this road is merging two lanes coming down one lane. Okay, that's a terrible drawing here, right? So as you see, where we go has not changed, right? So the fact that two lanes coming down a lane hasn't changed the destination. So that's why when we look at from a biochemical point of view, we can say that taking extra insulin or IGF-1 or any other growth factors doesn't do any good in terms of gaining muscle mass, which makes sense, right? As you see, both rest and exercise and IGF-1 do the same thing, moving inhibitor away from activation site of mTOR. So it doesn't make sense taking extra insulin or IGF-1 because what they're gonna do is gonna be the same thing, right? That's why we don't suggest anybody to take extra insulin or IGF-1 after rest and exercise. And also think about the people type 1 diabetes, right? Type 1 diabetes who cannot produce insulin at all can hypertrophy just fine. So all these kind of things saying again, taking insulin, we don't need to take extra insulin or IGF-1 to be able to increase muscle mass. Okay, so this was the first biochemical pathway, and second specific biochemical pathway to be able to activate mTOR is by bringing mTOR to its activator. Again, the activator of mTOR was rehab, right? So this specific pathway relies on amino acids, specifically leucine, which is one of the examples of brain chain amino acids. So why is leucine important? Because we have more leucine receptors on the membrane of our muscles. Okay, so leucine comes and binds its own receptor, which is called LAT1, and once leucine enters inside the cell, it causes a bunch of conjugated molecular reactions, and eventually it leads erect proteins to turn on, and that results in bringing mTOR to its activator, which is right here, right? Now we activated mTOR by taking protein that is rich in leucine. And if we give an example for that, we can say whey protein is the very good example for a protein that is rich in leucine. So by doing that, we activated mTOR, okay, and we did resistance exercise, and we moved inhibitor from activation side of mTOR. Now we've got completely two different distinct mechanisms. That means now we're gonna have more effect than either one individual. And if we can do this, do resistance exercise, and after resistance exercise take proteins that is rich in leucine, we can now optimize and increase the protein synthesis, so is results of strength.